This is the first section in the unit on logic. So we're going to introduce today what a statement is and kind of go from there. We will eventually get to the point where we can analyze statements and actually analyze arguments, but we got to start somewhere, so we need to start with what is the statement. A statement is a group of words or symbols that can be classified as true or false. So it doesn't matter what the result is, whether it's true or false, just the fact that the group of words that you have can be classified as true or false. So, for example, Annapolis is the capital of Maryland. That, of course, is true, but it is a statement. If I said Baltimore is the capital of Maryland, which is obviously not true, it's still a statement because it falls under that category. You can be classified as true or false. 5 is a natural number. I can say that's true or false. Algebra is a branch of mathematics. And you can even do symbols. So like 3 plus 7 equals 10. You can say that's true or false. So those are all statements. So you're probably wondering, what is a statement? Often in class when I go over this, the first thing I get is opinions. And that is correct. You know, if you said Breyers is the best ice cream ever, that's not a statement because it's an opinion. You can agree or disagree with it, but by logical standards, it's not a statement. Because to that, you know, it can vary from person to person. Also, questions are not statements. Obviously, if I asked you the question, how many courses are you taking this semester? You can't take that phrase I gave you and say it's true or false. Or a command like the parent says to the child, get out of here, for example. That is obviously not a statement. Determine if here's the first example, and what we're going to do is determine if the following statements or following examples, I should say, are statements. So the sky is blue today. Of course, you can determine if the sky is blue. When is the test? Well, that's a question. So that is not a statement. Some of these, if the wording is a little bit small, you know, feel free to bring up your PowerPoint and you can look at these, but I will read these out. This third one says math is difficult. If you can read that, that is not a statement, obviously, because it's an opinion. And then Germany won the soccer game is a statement. That can be classified as true or false. Yeah, they won, or yeah, they didn't win. I guess they could tie, but that still would mean they didn't win. So I guess it still works. All right. We're going to work on negating statements. Now, when we negate a statement, we just make a statement that has opposite meaning. So, for example, if Christopher Columbus says the world is round, then the negation of that statement would be simply the world is not round. And I guess that would be an opinion. It almost seems like it would be, but I guess the argument back then that the world was flat and their concept of the world being flat, that actually was proven wrong. So that, I think, will make it a statement. All right. All right. Negating statements that have either the quantifier all or some. And as you can see, if you have the quantifier all, for example, if I say all dogs bark, then you can negate one of two ways. You can say some dogs don't bark, and that's one of the things about claiming all. If you claim all dogs bark, you only need one counterexample to prove wrong. So really you would only have to find one dog that didn't bark. So that would be some dogs don't bark. Or like if you claimed, you know, all football games are played on Saturday. Well, if there's a game on Monday night, that would be enough to show that that's wrong, because you claimed all. So that's the idea, is all you only really need. You can say some are not. Another way to say that, and some like this better, and you can just say not all dogs bark is perfectly fine to claim that way. Now, if you start out with some, so if I say some cats have claws, well, I actually do have to show that all cats don't have claws. So a sum statement has a little less power, and it's a lot harder to, I guess, prove wrong if you think about it. Because like, let's go back to the football example. If I said some football games are played on Saturday, I'm pretty safe. Because only, you know, you would have to show that every football game is played on non-Saturdays, or, you know, something along those lines, which, you know. So yeah, I think you get the point, is that if I say some cats have claws, actually the negation would be all cats don't have claws. Or you can say no cats have claws is also a proper negation. And you can memorize these structures, by the way, but I think you can kind of understand them logically, what's going on. So if I said, you know, some football games are played on Saturday, well, the negation, you could say no football games are played on, no football games are played on Saturday. Which is basically saying that it never happens that there's a football game on Saturday, which obviously that's not going to go very far. Doesn't he live in Blacksburg in particular? All right, speaking of which, let's practice a few of these. Virginia Tech is a member of the ACC conference. Well, that would simply be Virginia Tech is not a member of the ACC. And I think what I'll do is I'll do the next two, and then you can finish this one out. I'm going to flip back because it's kind of hard to read that slide. The number 2 says, some flowers have petals. Well, there's the term some, so we know we got to go to all, or we can say no. So one way you can do that one is you can just say no flowers have petals. By the way, that slide has both solutions on it, but it might be a little hard to read, so I'm not going to bring it up, but feel free to go back and look over that later on. All math courses are worth 3 credit hours. Well, I claim all, so I only have to say some math courses are not worth 3 credit hours, or you can use the not all to negate all. So not all math classes have, or excuse me, are worth 3 credit hours. I'm going to abbreviate there. That's okay. All right. So again, you can negate an all statement by all. Not all math classes are worth 3 credit hours. On number 4, it says no lunches are free. That basically, if I go back to the slide here, I think the quickest way to explain this, no x or y. If you go backwards, it goes to some x or y. If you notice, no x or y. If you go backwards, it goes to some x or y. So what you can do is say some lunches are free. Now, if you do it, that's it. Basically, you can also translate that as all lunches are not free. And if you negate all lunches are not free, the all becomes some, and not free becomes free. So either way it works. So some lunches are free. Okay, I want to introduce a little bit about converting symbols. If you can't read the slide, let me see if I can change the color on that. Do that real quickly. Okay, sorry about the interruption. I just paused it for a second. That slide was colored so hard. I'm hoping that this is a little bit easier to read. So, the symbol for and looks like an upside down V, and the symbol for or is upright V. Now, if you think about it, go back just a little bit ago to sets. Remember, and was intersection, was upside down, or meant or union was or, the union was upright. So it's the same pattern. The U was upside down for and the U was upright for or. So it's kind of the same setup. If then it will be represented by an arrow where the first part's the hypothesis, the second part's the conclusion, and then if we're doing a negation, it's squiggle. I'm going to skip that one. So here's the example I'm going to do. And I'm just going to do a few of these. So, B represents the game is in Blacksburg. C represents the game is in Charlottesville. W is Virginia is favored to win the game. T is Virginia Tech is favored to win the game. And I guess W is like UVA, Virginia is favored to win, if you're wondering. And then N is the game is that night. So, I'm going to do this one, B, arrow, T. Well, arrow represents Blacksburg. Or excuse me, if then. I got ahead of myself. So arrow represents if then. B represents Blacksburg. And then T is favored. Texas favored to win. So this is going to translate to this. If the game is in Blacksburg, then Virginia Tech is favored to win. And that's translating a symbolic statement to a statement in words. It's what I've just done. Now, if you have like C arrow W, this would be if the game is in Charlottesville, looking at the key for what each statement represents, then Virginia is favored to win. I'll do one more. Negate the upside down, which is and. Upside down V looking thing is and then and is the next symbol. So this will be basically the game is not in Blacksburg. I wanted to do one negation. And as our connector. The game is at night. Now, one little kind of silly connection I make in class is the fact that this is kind of like when you learn to use and or when you're in English class, you're connecting two sentences. and making one sentence, a compound sentence. So it's kind of similar to that idea. And if you notice on one of the slides, I have a link. It's basically to the Schoolhouse Rock conjunction, junction, what's your function, and that always remember that one as a kid. I always think of that when you do this, because it's kind of a similar idea. You're hooking up statements rather than clauses. But anyway, there is that, if you're wondering where that link comes from. So this is going from a symbolic statement to a word statement. I'm going to leave a couple of those. I think that was I'm hoping that's enough just to do a few of those. And you can practice the others and check them up here. I got the slide to check them. Let's do one more. These are the exact same statements. B, C, W, T, and N are all the same thing in this example. And I'm going to do the first one that says, if the game is in Blacksburg, then the game is at night. Well, part A, this is number 6, I guess. Well, the game is in Blacksburg is B, and then it's an if-then. So we'll go, if the game's in Blacksburg, then it's at night is capital N. So B, arrow N, that's all you need. Likewise, we could do the last one. The game is not at night, which would be negate N, and the symbol is that. Virginia Tech is not favored to win, which is negate T. Remember, Tech is favored to win is T. So negate T. And I have some things about special forms of the conditional. I'm probably not going to test you on that stuff, but if you're curious with that, I'm going to handle it that way. I think I will take that off the test. But, you know, look at it. It kind of helps you understand the conditional, which is the if-then statement, a little better. So, that wraps up this section. The next thing we will do is we'll move on to truth tables.